Well, here we are. We're moving into three-dimensional thinking. Three-dimensional thinking. All of you future engineers out there, this is going to be kind of a standard for you moving forward, and many other majors as well. So, we have our x-axis and we have our y-axis. We're simply going to add a z-axis to measure in our third dimension as we get started with this. There are other coordinate systems that you will meet later on, but right now we're going to just look at the simple concept of x, y, and z in that order. What you see here is the standard orientation that our textbook uses and that I'm going to use during the semester. They don't have to be X, Y, and Z, but if you change the order of these three in my classroom, you have to change the labels to go with it. But I would recommend strongly not doing so unless there's a good reason out there for doing it, like by the type of question that's asked or if my direction requires it. So, X, Y, Z. How many regions is space divided into by these three axes? Space is divided into how many regions? Well, that's right. There are going to be 8 of them. There is a region, so here's the X and Y is positive quadrant, quadrant 1 in the good old days of flat world. Above that quadrant 1 is called octant 1. We'll write that down in a moment. We're not going to number all of them. There's another octant back here and over here and over here. And there are 4 more where Z is negative below this gray XY plane. So there are 8 total, and they are called octants. We are only going to name the first octant. That is the place where X and Y and Z are all positive, which would be this octant here. There are likely numbering systems that you could refer to. There's not necessarily just one numbering system, though. The only numbered quadrant our textbook and that I will use is the one that's the first octant where all coordinates are positive, X, Y, and Z. Now, let's just try a little trick here. What if we were to want to plot the point 2, 0, 0? Where would that be? Well, that's right. 1, 2 units over, that would be right here. And where would the point 0, negative 4, 0 be located? Well, if X is 0 and Y is 1, 2, 3, negative 4, and Z is 0, that's just a point on the y-axis back there. And what about the point 0, 0, 5? 1, 2, 3, 4, 5. That's where Z is positive 5, but X and Y are both 0. It's not too difficult to plot a point if it's on the axes, but we are just not going to plot many points, and we certainly don't have anything that looks exactly like holographic or three-dimensional looking graph paper. This is a sketch, more or less. We should be able to recognize where the points are located, and if there was a good rendition of a point plotted, we should be able to say, oh, I know those coordinates are, and we'd be able to write them down. Now, we have been algebra students for a long time to get to this point in third semester calculus. So, what if we had a graph that looks like this? We're looking at what's shaded in green here. So here is the XY plane down below, and here is our Z value up here, Z axis up here, labeled 1, 2, 3, 4. This green plane is the place where all z values are positive 4. So this point here, I don't know what the x and the y coordinates are, but I do know that the z coordinate is 4 at that point. And same here. I may not know what x and y are, but I know that z is 4. Z equals 4 would be a plane that, if you want to use simple terms or simple description, it's 4 units above the xy plane. The problem with that type of description, the word above here, the problem with that word above is it's only above, upwards, because the x and y are down here. If the x and y were labeled in a different place, it may not be above, so you have to be careful with that. This one here, this plane here, that's where y is -2, and every point on this green plane has y values that are -2. That would be its equation. So you could say it's 2 units to the left of the xz plane or wall, but it's only to the left because this was x and this was y and this was z. It's only to the left because of that. So using words like to the left assumes that people already have the orientation of the axes the same. Now, you've heard me say xz plane and xy plane. Let's end this little segment looking at these 3 planes in particular. The xz plane, sorry, that would be a typo. How about we call it the xy plane? XYZ. There we go. The xy plane, our traditional plane. You know, this was the first quadrant when we had only 4 of them to worry about. The xy plane is where all z values are 0. Sometimes I'll say it's on the ground. It's on the ground. All right. This next one here is the xz plane. Well, the xz plane separates your positive y values from your negative y values. So that is represented by the equation y equals 0. And finally, the yz plane separates the positive x's out here and the negative x's, which are back there. So the yz plane is where all the x values are equal to 0. Those are basic equations of planes, but they are quite critical, especially moving into our last 2 chapters of the course. Now, stay tuned, follow along for the few next segments, and we'll see a little bit more about the introduction to 3 dimensions. Until then.